I want to thank everybody for sticking with us this long. It's been a long day, but I honestly think this presentation is going to be well worth it. So I'm joined here not only by Chris, but by Dave Ismer from Technome, who is our AMPD Data Operations Manager, and by Dr. Aline Appelmans from the Foundation for NIH, who manages the AMPD partnership. AMPD wouldn't exist without either of them, and so I want to thank them for helping us here today. Our goal for this session is to get you started with using the AMPD data. You are part of this data set, and we really want you to have access to it and use it. So I'm going to start off with a brief introduction to the program before turning things over to Dave, who's going to do the hard work of showing you how to use the platform. So as all of you know, a lot of money has been invested in the Accelerating Medicines Partnerships. These are collaborations between government agencies like the NIH and the FDA, with life sciences firms like pharmaceutical companies, and multiple nonprofits, including patient advocacy groups. The overall goal of the AMPS is to deconstruct disease pathways so that new diagnostics and therapies can be developed at an accelerated pace. There are currently 4 AMPs, and one of them is my personal favorite AMP, Parkinson's disease, which was launched in February of 2018. It has a similar goal as the other AMPs, and it is meeting that goal by leveraging both existing cohorts and platforms and pipelines for the purpose of creating a huge publicly available clinical and omics data set. This slide is a summary of the platform, just a quick overview of how it works. It includes a public-facing website where users go to register for data access. It includes the Terra platform, a collaboration between the Broad Institute and Verily, where the data is accessed and analyzed. And it includes the Google Cloud Home, where the data lives, and where a few additional analyses can be done. This slide summarizes the data that's available in AMPD. I think you've seen it before. It includes the longitudinal clinical data from our 4 amazing cohorts: the Parkinson's Disease Biomarker Project, the Michael J. Fox Foundation's Parkinson's Progression Markers Initiative, the Fox Foundation NINDS collaboration, BioFind, and the Harvard Biomarker Study. It also has the whole genome sequences and transcriptomics analyses that were done on the blood samples from these amazing cohorts. I think this database is unique for the richness and complexity of the data that's harmonized here. And you can see the numbers. These are huge patient numbers. So we're really, really proud of this data set. In order to be consistent with HIPAA requirements and with the NIH's genomic data sharing policy, we have a 2-tier system for data access. Tier 1 provides access to the de-identified longitudinal clinical data that was harmonized across the 4,000 plus subjects. Access to Tier 1 requires that you sign the data use agreement. Tier 2 data, which includes the Tier 1 data, plus the individual level whole genome sequences and the longitudinal transcriptomics data, is accessed through the data use agreement that's signed by you and your signing official. We think both tiers have extremely useful data, and your research interests will determine which one works best for you. But I'm going to stop here now, and I'm going to turn it over to Dave, who's going to show you how to make use of this at both levels.
Thanks, Deb. So the method that we generally recommend for accessing the AMPD data is the Terra platform. That's not specific to AMPD. It's run by the Broad Institute. But it provides a nice interactive way to work with the AMPD data. It gives you a lot of the tools that you need to work with the data in the cloud. But in order to use Terra, you do have to register. and you have to get an active billing account. So in order to follow along with our demo today, you should have already gotten a Terra account and registered for a billing account. If you haven't done that, we have the instructions here. So if you, and the demo will be recorded. So if you don't have all the accounts you need to do it, you can come back, look at this, set up your account, and then follow along with the demo yourself. So registration is free. There are terms of service, and you have to, when you register for the billing account, that will set you up with a Google billing account. To give a brief overview of what Terra does, it primarily does three things. It lets you go through and discover what data there is available in AMPD, as well as other publicly available data sets. It lets you do analysis on that data within the cloud, and it lets you collaborate with other people. The main thing that we're going to be looking at today is a Jupyter notebook, and that's a way that you can create code that works with the data. You can then do write-ups on it. You can run it and save the output from it, and then you can share that with other people who can then look at it, run it themselves, see if they get the same results. So what we're going to do today, we're going to go through several steps. We're going to show you how to log into Terra. We're going to show you how to clone our demonstration workspace. We're going to show you how to find a set of subjects that you're interested in the Data Explorer. We're going to create a cohort and send that into a workspace. And then inside that workspace, we're going to analyze the data about that cohort and work on some Jupyter notebooks. So we'll actually start out in the AMPD portal. So if everybody could open a browser and go to amp-pd.org, that will get us where we need to be. And once you're in amppd.org, on the top right, you'll see a button that says Workbench. That launches the Terra platform, so that should open it for you. And if you've already created an account and logged in, it will probably drop you right into your account. If you haven't logged in yet, you should see a Welcome to Terra page. And then when you say sign in with Google, you have to select the Google account that you want to log in with. This should be the one that you created, your AMPD account that you used for your AMPD registration. So I'm using a test user with Tier 2 access. So what we're doing in this demonstration, we're going to try to find a set of subjects that we're interested in. We're going to pull out some assessment data and some genomic data on those subjects, and we're going to do some analysis. So what we're trying to do is to find out whether there's a correlation between the GBA mutation and the progression of Parkinson's disease in our subjects. We're interested in specifically male subjects with Parkinson's disease for whom we have whole genome sequencing data. Once we find the cohort, the subjects that we're interested in, we're going to look at some assessments, including the demographics information, the MOCA assessment, and the MDS-UPDRS assessment. We're going to look at genetic data on them, specifically looking at the GBA mutation, but also other known mutations that are in our data. And we're going to try and find out if there's a correlation, as I said, between the GBA mutation and the progression of Parkinson's disease. So if everybody's logged into Terra, I'll give you a brief overview of what Terra is and walk you through one of our workspaces. So as I said, Terra lets you work with the data and share code with other users. When you go into it, you'll see, initially you'll see a list of workspaces that you have, either you've created or that you have access to. That's how Terra divides everything up. you create a workspace, and then within that workspace, you can store data, you can store code, you can store output, you can store files, and you can share those workspaces with other users. We've created 2 getting started workspaces, and these are what we recommend people come into, open them up, look through all the notebooks and the code and the data that are in there. There's a set of instructions when you go into it that will show you how to use it. And if you go through those, it'll give you a good primer on how you can use the Terra workspaces to access the AMP-PD data and to do things with it. We've also created our AMP-PD demonstration workspace, which is what we'll be walking through today. So as I said, we created the 2 getting started workspaces. One is for tier 1 and the other is for tier 2. The tier 1 gives you gives you examples of how to access the clinical data in the system, and then the tier 2 adds to that the genomic information that we have in the system. So I'll open up the getting started tier 1 workspace and show you through. There's a lot of information on the screen, but it's divided up into these tabs along the top. The first tab that you'll go into is the dashboard, and this gives you a lot of information about the workspace. Gives you a description of it. For our getting started workspaces, we put in next steps, some information as to what you can do in there. Different users will put different information into the dashboard of their workspace. There's a data tab. This can have data tables, it can have files. The files work a lot like an FTP site, so you can upload and download files into a cloud account. The workspace data is where you can set configuration parameters up so that your notebooks can access, in this instance, so that notebooks can access our tier 1 data. The heart of the workspace are the notebooks. As I said, these are small programs that are written in a system where you can also put descriptive information and store the outputs. So if I click on one to go into it, it's all of the boxes with the gray background. Those are boxes of programming code. In this case, written in Python, but they're also available in R if you're more familiar with that. So yeah, the gray boxes have the code. Anything that's got a white background is descriptive information or outputs. You can also see here, when you run the code in one of those cells, the output shows up below it. And in this case, we've done a query on the AMP-PD data, and you can see the output of that query below. Going back to the workspace. So that was the notebooks. We have two notebooks in our demonstration for today that I'll show you. Workflows, this allows you to do multiple, you can run a program multiple times in parallel in the cloud. For a lot of our processing for AMP-PD, we're doing processing on thousands of subjects, and if we were to do it in sequence, where we have to wait for one to finish before we start the next one, it would take months or years to do some of our processing on it. But these workflows allow you to split them up and run to create a virtual computer for each subject, and then you can process that subject's data on that one virtual computer, and then they'll put all the data back together at the end. So this lets us do 4,000, 10,000 subjects all at the same time, running on thousands and thousands of computers in the cloud. And this is available to anybody. If you're doing something, some massive processing, it can get expensive, but there's also a lot of work that you can do for minimal cost. You can split one subject, you can process each one of their chromosomes in a separate machine, and that vastly speeds up a lot of our single subject processing. And the job history tab, if you run workflows, this job history tab lets you go in and see what the progress is of that, lets you see the outputs. If there are any errors in it, you can see that there. That's just where you go to look at all of the workflow processes that you've run. So that's our getting started tier 1. We also have the getting started tier 2 workspace. I won't show you that today. But I highly recommend that if you have access to it, you go in and look at it yourselves. The next thing we want to do is to go into the demonstration workspace that we'll be using today. And as I mentioned, in the notebooks, we have a tier 1 and a tier 2 demonstration notebook. In order to run this demonstration, we can't just open somebody else's workspace and run it in there. We have to actually clone it, make our own copy of it in our own billing account, and then we can run that. So if you go up to, if you open the workspace that you want to clone, and then you go up to the snowman menu, when you click on that and you say clone, that should give you the option to create a workspace in your own billing project that's an identical copy. So you can give it any name you like, but as you see a lot of your own workspaces and other workspaces that have been shared with you, it's very useful to be able to know which ones are yours. So when I'm making a copy, I usually preface the name with my name so that I can easily see them. They're all sitting together. We have to select the billing project, and this should be the one you've created. The authorization domain lets you choose it lets you limit the number of people that you want to share it with. It doesn't automatically share anything, but if you set an authorization domain, that sets up the list of people who you can share it with. For our purposes, we'll just go with the default one and say clone the workspace. So when you click clone workspace, it should take you to it. I've already created this one, so I'll just open it. So now we're in the demonstration workspace. As I said, what we want to do for this demonstration is to look for a specific set of subjects. We're looking for males who have Parkinson's disease and for whom we have whole genome sequencing data in the AMP-PD database. So the way we find those subjects is through something called the Data Explorer. If you click on the hamburger menu in the top left of your screen, you should see an option for library. If you click on library and then click on the data tab, this will open up the data library. This page contains a number of publicly available data sets. There are some very, very useful ones with large numbers of participants and a lot of data in these. The one we're going to use specifically for this demonstration is our AMP-PD Tier 1 data set. So if you click on the Browse Tier 1 Data button under the AMP-PD, that will open up the Data Explorer. It should open up the Data Explorer. There we go. So the Data Explorer it's giving you information in a visual way on all of the data that is in our AMP-PD database. The Tier 1 is giving you information specifically on the clinical data. If you open up the Tier 2 Data Explorer, that will add in the genomic information. But we want to use this to find our subjects of interest. So all of the data is in these cards that you see. The cards are histograms showing you how many subjects fit that particular criteria. So if we look at our card for study, this shows you the 4 studies that make up our current AMP-PD data set. We have PPMI, PDBP, HBS, and BioFind. When you hover over the bar on there, it tells you how many subjects meet that criteria. So in this case, When I hover over HBS, that tells me that 876 subjects are from that HBS study. When I go to the sex at birth card and I hover over female, that tells me that 1,908 subjects are female. Likewise, for age at baseline, it gives you the breakdown there, diagnosis information, case control. Then we have who has RNA data, who has whole genome sequencing data. And in order to filter this, what we want to do is to start clicking on some of these things. As you can see in the top right, we currently have 4,298 participants that meet our criteria. That's all of the subjects that we have in the AMP-PD database, because we haven't put any filters on them. As I said, we want males with Parkinson's disease with whole genome sequencing data. So we'll start by clicking on male, and that selects only the male subjects. So now we're down to 2,390 subjects, and all of the other cards have reloaded themselves to give information about this cohort specifically. So we're now looking at just the males. So when we go back to HBS, we now have 503 subjects instead of what we had before. We also said we're only interested in subjects with Parkinson's disease. So to get rid of the control and other subjects, we're going to click on case. And we're going to click on has whole genome sequencing samples. And now when we look at it, we have 1,478 participants that meet the criteria that we put in there. If there's criteria that you want to filter on that isn't showing up here, you have the ability to search our AMP-PD data for any piece of data that we have. So if you're only interested in subjects who are on levodopa at the time of their baseline visit, you can type that into the search, and that'll show you all of the different options. If we're interested in subjects who are on levodopa at the time of their baseline visit, we'll select month 0, and that adds a card here for you. You can do that with any of the data that's in the AMP-PD database. It's a really powerful feature. So if we wanted to, we could select subjects who were or were not on levodopa at the time of their baseline visit. But for the purposes of our demo, we'll leave it just at males with Parkinson's disease for whom we have whole genome sequencing data. So in order to export this list of subjects to our workspace, we'll click on the Save Cohort button. And it asks you to give it a name so that you can find it later. You can give it any name, but for the purposes of our demonstration, it has to be called demo_cohort, all lowercase. The notebooks that we've created, the demonstration notebooks that we've created, are all expecting this particular name. So again, it has to be demo_cohort, all lowercase. Once you put that in, you can hit save. And it'll give you the option of either starting with a new workspace, where it'll take your cohort information, it'll create a blank workspace for you to work in, or you can choose an existing workspace. We're going to choose the workspace that we cloned. So if you click on start with an existing workspace, when you hit the select, you should see as an option the workspace that you just cloned. So I'll select that. And I've already brought this cohort into it, but for yours, if you click on import, that should bring it in, and it'll open up that workspace for you. For me, I'm going to go into my workspaces and find it. So it should have opened up the workspace for you into the data tab. So when we looked at it before, there were no tables included in it. There was no data there. But now, because you've saved a cohort, you should see 2 data tables. One is BigQuery table. This is just a list of all of the data tables that are available in our AMP-PD clinical data. The important one for us is the cohort table. So if you click on that, this will bring up a list of all of the cohorts you've got saved in your workspace. If you want to have a case and a control cohort for your study, or if you want to have several different cohorts for whatever reason, you can save as many in here as you want. Each one will have the cohort identifier, which is the name we gave it. It's got the data set that it was pulling from, in this case, our AMP-PD clinical data. It has a URL that you can use to, if you copy and paste that URL and put it into a browser, that will bring you back into the Data Explorer with all of your selections selected. That's very useful if while you're working with the data, you realize you need to change it somehow. You can open it back up, make your changes, save a new cohort, and then you'll have a second one in here that you can use. For our purposes, the most important thing on here is this query. So this is a SQL query that you can run in a SQL engine or in your Jupyter notebooks. This SQL query will generate a list of participant IDs for all of the subjects that are in your cohort. This is what we'll use in our notebooks to limit our queries to only those subjects that meet our criteria. Once you save a cohort into your workspace, if you click the checkbox and you go up to the snowman menu, there's an option to open with. And if you click on that, it'll give you a choice between the Data Explorer and the notebook. If you open it in the Data Explorer, that will take you back to the Data Explorer. If you open it in a notebook, that will actually create a new notebook for you with information and examples of how to use and access the cohort that you created. You can give this any name you want. I'm going to call it cohort demonstration. And you have to select the language. The notebooks in Terra can be either in Python or in R. I'm more familiar with Python, so that's the one I'll choose. If you're more familiar with R, you can choose that. It works equally well with both. Then I will create the notebook, and this will open it up for you. And in here, you can see the code that it's created to help you access the data. We're not going to run this notebook because we have some demonstration ones, but in future, if you create your own cohort and then you create this notebook, this gives you a good shortcut. All of your queries are already there, so you can just cut and paste them or modify them to get the data you need. To give you to sort of give you an overview of how the code in here works. First, it's setting up the name of the cohort for you. Then it's doing it's importing the libraries that it needs in order to access it. Libraries are small subsets of code. They're pre-compiled libraries of commands that you can use in your program as a shortcut. So this is a lot of programming is already done for you. You just import the library, and then when you make calls to it, it runs that for you. The next step is to get the cohort definition. As I showed you, we saved it into the data tab. In order to use it in a notebook, you have to actually pull that into your notebook from the data tab, and that's what this code does. And the rest of the information in here are pieces of code that you can cut and paste to do things with that data. So this one queries the cohort. This one lists all of the tables you can access. This one joins to find some information about the participants. This one gives you some visualization of the data. It's a very useful, very basic set of instructions for working with the data. But we're going to go out and we're going to open up our demonstration workspaces. So if you go back up to the hamburger menu and you choose your workspaces, that will take you back to the, oh, sorry, we didn't actually need to go all the way back here. But this takes you out to the list of workspaces. So let's select the one that we cloned and go into that. And we'll go into the Notebooks tab. And in the Notebooks tab, you should see three notebooks. The Tier 1 demonstration, the Tier 2 demonstration, and the cohort demonstration, which is the one we just created. So if we click into the Tier 1 demonstration, this is our demonstration for working with the clinical data in AMP-PD. So it opens it up in read-only mode, and in order to edit it or run it, you have to go into edit mode. So if you click on the edit button on the top left of the screen, that will now start a virtual machine for you and load your notebook into it. This will take a little while. If you've already created a notebook runtime for your billing project, this will take a minute or two. If you haven't created one, you're doing it for the first time, you'll have to tell it how, you'll have to configure that notebook runtime. If you don't have one set up, you should have seen a drop down come out on the right-hand side of your screen. In there, it lets you put the configuration of that virtual computer. So you can choose the number of CPUs, you can choose the amount of memory that you want in there, the amount of disk space. For the purposes of this demonstration, we'll just create the default. So just leave it as it is and just click on the create button. And as I said, this will take a few minutes. So I'll talk to you a little bit about what these notebook runtimes are. And then we'll have a minute or so for people to ask any questions, if there's anything you need to ask. So in order to run the program that you're creating in your notebook, it needs to have a computer to run it in. In order to make sure that the code that you're running runs in the same way on somebody else's computer, you can make sure that the configuration is the same. A lot of times when you see a notebook, it'll have instructions that say, in order to run this notebook, you have to have a certain amount of memory, a certain amount of disk size. So you can, if you have created a runtime that doesn't have enough memory or doesn't have enough CPUs or disk space, when you open up that different runtime, you can, you can open up that notebook and then you can go into your runtime and you can click on the configuration and you can actually change that. You can choose a high compute power, or you can do a custom one where you set up specifically the number of CPUs and the amount of memory and disk you need. You can also change the default configuration, the default software that's installed on that computer. There are a number of predefined ones that are very useful for different purposes. We should have a minute or two. Are there still people who are waiting for their runtime environments to start up? Is everybody ready to begin? I'll take the silence as a yes. But if there are any questions anybody has before we start, we can take a minute or so now to answer those. Does anybody have any questions? No? Okay. Great, we'll jump in. So everybody should see that notebook opened up in the edit mode in front of them. As I mentioned, it's broken up into cells. So these are any piece of code will be in this gray background. You can click on it and you can run specifically that piece of code. Any descriptive information, as I said, is on a white background. This is just like HTML. You can put in titles, descriptions, whatever you want in there. So in order to run a cell, you select that cell and then you click on the Run button. And that will then load it into the notebook runtime. It will run that specific cell. It'll show you any output from it, and it'll save the results of that. And it'll save your state as you're stepping through your program. So it's a really nice thing about these Jupyter notebooks. You can run them, you can run each piece individually, so you can see where you're running into problems. If there are any errors, you'll know right away rather than having to wait till the end of the program and then try and debug from there. It's a very nice, easy, straightforward way to do programming. So the first step in this demonstration notebook, you have to install the software. As I said, for your notebook runtime, they can come, if you choose the right notebook runtime, it will come pre-configured with a lot of the software that you need. For our purposes, we needed to install a couple of additional libraries. So that's what this first cell does. So if you click Run, it'll take a few seconds, but it should install that package for you. You can ignore this error message. It's just telling you that that there are some updates coming in the future. The next one we'll go to this load libraries. As I said, there are certain libraries that you need, that our notebook needs in order to run. You install the packages or they come pre-installed, but in order to let the system know that you want to use them in your notebook, you have to do these import commands. So if you run this load libraries cell, that should do that for you. There are a number of functions that are set up for you in here. These are functions that we'll use to access the AMP-PD data. So if you run that, it will prepare those for you. This is an important one. In order to tell it how to get to AMP-PD data, we have to set up these global configuration items. So in this instance, we have these two, which give it the instructions on how to reach the AMP-PD data set. This is the Tier 1 data set. So that's at AMP-PD Research 2019 V1 release 1015. When we do another release, or if you want to get to Tier 2 data, you would put in a different address, and that'll get you to that other data. But this is the data in our version 1 release that we'll be using for this demo. So if you run this cell, that will configure it to access that data. As I said before, the cohort definition is a SQL query that's stored in the data tab. In order to bring that definition into your notebook and use it, we'll run this cell, and that goes out to the data table, pulls back the query, and you can see it here. So this is the SQL query that we'll be including in our other queries, so that we can get data only on the subjects that met the criteria we put. So we're looking for males, we're looking for ones with whole genome sequencing data, and we're looking for case subjects. So what we'll do now is to actually read some data from the AMP-PD database. So if you run this cell, this is running a SQL query against our AMP-PD BigQuery database, and it's pulling back the information from the demographics table on all of the subjects that were included in our cohort. It shows you some basic information about the data you've brought back. What you see here is that you've got 1,478 subjects. Of those, a little over 1,000 have a GUID. Most of the rest have the other demographic information: age at baseline, sex, ethnicity, race, education level. So this gives you a quick snapshot of what you just pulled back from the database. We can also display the actual data itself that we brought back. So if you run this cell, this does a head command, which gives you the first 5 rows of data. So as you can see in our data here, we have 3 subjects from PPMI, 2 subjects from the PDBT study. We have a variety of baseline visits and screening visits. And you can see there are different education levels. And you can see that all of them are male because that was the filtering criteria we put in. So we can also do some visualization on the data we just pulled back. So what we have here is a little snippet of code. If you run this, it will produce this histogram showing you how the age at baseline is broken up through all of our subjects. And as you can see, that curve is centered around the late 60s. So that's what the age of the subjects in our in the cohort that we're interested in looks like. In addition to histograms, you can do other visualizations like pie charts. If you run this piece of code, it will produce this pie chart for you, showing you the breakup of education level in our subjects. So you can see that about 2/3 have 12 to 16 years of education. Another 25% or so have greater than 16 years. And then we have a small percentage that have less than 12 years or unknown. We can also do statistical analysis on the data that we're pulling back from the BigQuery data set. So in this cell, this is an example of how you can do some mathematical analysis on them. We're pulling some simple things. We're pulling the mean, the standard deviation, and the quantile ranges. So as you can see, the mean value for our age at baseline is 64.5 years. Standard deviation is 9.8 years. We can also do a similar thing with our MoCA assessment. In here, looking at the MoCA total score value, we can see that the mean value is 25.7. We've got a standard deviation. You can see what the quantile ranges are. Similarly, for the MDS-UPDRS assessment, if you're on this one, it'll do it on that. But in order to do useful analysis on the data, what we have to do is combine these together. So in our next example, the query we're going to run here pulls back both MDS-UPDRS summary, Part 3 summary score information and the education level from the demographics data. So as you can see, we're pulling the participant ID, the education level, the visit names, so this will tell us whether it's baseline or a follow-up visit, and then the MDS-UPDRS Part 3 summary score. We're pulling that from our demographics table and from our MDS-UPDRS Part 3 table. We're combining on, we're looking for only ones where the summary score is not null, because we only want the ones that are of interest to us. And we're only looking for the ones that are, for the subjects that are part of our cohort. So adding this cohort query in here, that adds our SQL query to this query and pulls back just the subjects we're interested in. So if you look at the results that we got back, you can see that we got 7,424 results. And we're seeing more results than we have subjects because a lot of our subjects had multiple visits. So we're seeing a number of different MDS-UPDRS assessments for each subject. If we do a head on that data, we can see that this is the data we're pulling back. It's the subject ID, the education level, what visit it was, and then what was their MDS-UPDRS Part 3 summary score. To do something useful with that data, we have this next cell. And if you run this, it will produce a box plot showing you what the data looks like for each of those education levels. So you can see here with the different education levels, the data is different, but it's all centered around roughly the same point. Our unknown subjects, we have a very small number of subjects there, so that's why we're not seeing any range for that. But as you can see, we're not getting particularly interesting results because there isn't really a correlation between the progression of Parkinson's disease that we're seeing from that Part 3 summary score and the education level. It's roughly the same. But what we said we wanted to do in our demonstration was to check and see whether there was a correlation between the GBA mutation and our Parkinson's progression. So what we want to do is to bring genomics data into this. In order to do that, we have to close out of here by clicking on the X, and we have to go into our Tier 2 demonstration. As I said before, Tier 1 can only access clinical data. In order to get to the genomic data, you have to go to Tier 2. So any of you that only have Tier 1 access, you'll still be able to run these queries. But when we run the queries that try to access Tier 2 data, it'll show you an error message. If you request Tier 2 access and you're approved for that, then you'll be able to come back in here and run it, and it would be successful. So again, now that we've brought up our Tier 2 notebook, we'll click on Edit. And we'll go through, the starting part of this is very similar to the Tier 1. So it has to install the software. So click on that cell and click Run. And after a couple of seconds, you should see the same message that you got before. We'll do the load libraries. So run this, and that's the same as before. Same with the setup utility functions. If you run this, they'll be in there. This one is a little bit different. Our notebook globals, in addition to the Tier 1 data address that we had in the Tier 1 notebook, for this one we've added Tier 2 as well. As you can see, Tier 1 was in AMP-PD Research 2019 V1 release 1015. Our Tier 2 data is at AMP-PD Research 2019 V1 release 1015 Tier 2. So this sets it up so that when our query says we want to get to Tier 2 data, it knows where to go for that data. Our cohort definition, if you run this, that's exactly the same as it was in our Tier 1 data. And now what we want to do is to run our query to pull back the MDS UPDRS Part 3 summary score and our mutation information. So in here, we're pulling back our participant ID, our Part 3 summary score, and then we're pulling back whether or not the subject has a GBA mutation, a LRRK2 mutation, an SNCA mutation, and then we're pulling back one that says whether they have any mutation at all, any of these known mutations. We're getting that from our MDS UPDRS Part 3 table and from our AMP-PD participant mutations table. And we're looking specifically for just their latest MDS UPDRS assessment. So we're looking for the maximum visit month because we don't want to get multiple results back that will throw our data off. We're joining on participant ID, and we're looking just for those subjects that were in our cohort. So if you run this, you'll see that we get 1,600 results back, of which 1,200 have a summary score. And then we have mutation information on all of them. If we run this next cell, this gives us a histogram showing the spread of MDS UPDRS Part 3 summary scores in our cohort. And as you can see, it's centered around sort of the mid-20s is what we would expect to see for most of our subjects. If we run this next one, this shows us a visualization of the mutations that we have. So within our cohort of 1,400 or so subjects, we have 142 that have that GBA mutation, 110 that have the LRRK2 mutation, 5 that have both the GBA and the LRRK2, And then we have 9 subjects who have the SNCA mutation. All of the rest of our subjects have no known mutation. So what we're going to do now is to run a query, or not to run a query, sorry. So we've already run our query to get the data back. What we're going to do now is to run our visualization. So this is creating another box plot, but it's comparing the, it's analyzing to see whether there is a correlation between the MDS-UPDRS Part 3 summary score and any of those known mutations. And as you can see, the spread of MDS-UPDRS Part 3 summary scores for no mutation, it's centered exactly where we expected it. Similarly for the GBA mutation, which is what we were hoping to find a correlation with, we're not seeing much there. The LARC2 mutation, similarly, it's about the same. But when we look at the SNCA mutation, we see that there's a significant difference here. Now this is a small, it's a small cohort, so we don't necessarily know that this is a meaningful result, but it's definitely something worth looking into. So this is ultimately what we were trying to do. We were trying to look at a correlation between known mutations and Parkinson's progression, and we used the Part 3 summary score of the MDS-UPDRS as our proxy for Parkinson's progression, and we're looking at subjects that meet these various criteria of known mutations. So that's what we wanted to do with our demonstration. Is just step you through these to show you a real-world example of how you can use these Jupyter notebooks to do some analysis on our AMP-PD data and to find results that would be useful to you. And with that, Chris, could you take that back? I think we had a questions slide on the slide deck. And we'll take this opportunity. If anybody has any questions, we have a very short time left. But if you have any questions, I'd be happy to answer them.
Hi, Chris. Hi, David.
Hi.
Hey, can I ask a question? I'm sorry.
Sure, please do.
Just one thing kind of confused me. What do you suggest? In which case we should use a notebook? In which case we should use a workflow? What's your recommendation?
So the workflow is useful mostly when you want to transform data. So we use that for doing variant annotation. We use that for converting from a CRAM file to do VCF, from CRAM to VCF, or reheadering if we want to change, if we need to change some of the header information over a lot of subjects. We would use the workflows for that. For actually doing work on single samples or sets of samples, for analysis work, the notebooks are better for that. You can do, it's ultimately, they're just different ways of running programs in a virtual machine in the cloud. But the workflows are good for doing a lot of subjects, doing a transformation to a lot of different subjects or files. The workspaces are useful for doing things on a single machine. So it really comes down to whether you want to do things over a lot of different machines or do it a lot of times, or if you just want to do it one time on one machine.
Thank you.
Sure. Okay. If there are no more questions, I'll hand it back over to Deb.
Thank you, Dave. That was a really great presentation. I want to tell everyone that we're going to try and get this posted so that if you didn't remember something or you missed something while you were setting up an account, it'll still be there for you to walk through. We also have a lot of support. The Terra platform offers a lot of support. AMPD offers some support. So email us questions and we'll try to help you.
Yeah, Deb, I think Liana has a question.
Yeah, I do. You can finish up though, Deb. I can ask my question when you're done. Sorry.
No, that's okay. I did see your question about the Google credits, and I think, you know, it depends. It's hard to answer your question because it depends on what you're doing. If you're going to run every single whole genome sequence and the transcriptomics and bring it all in, it's going to be a lot more than $300. If you're doing the kind of analyses Dave was showing you, it's pennies to dollars. So it really depends on what you're doing.
Okay. And then, am I understanding it correctly? And just jump in if I'm how to think about DMR versus the AMP-PD platform. My other question is that, so if I'm if I'm only interested in data analysis, genome sequencing, and I don't actually want samples, so I don't want CSF samples or serum samples, I'm interested in a question that big data and epidemiology can help me with. Is there any reason I would go with DMR over AMP-PD? Or it sounds like, from what you're describing, AMP-PD would give me more power because there's simply more people in it. Am I understanding it correctly in terms of the information and how to think about the different data sources? Or can you jump in and elaborate on that?
Yeah, well, when you're talking about the DMR, you're talking about the PDBP DMR?
Yeah, PDBP DMR, yes.
Yeah, well, we don't have any of the whole genome sequencing data in there.
Okay.
We only
some,
have NeuroX. That's the only data we really. So
right, we have the NeuroX.
Right.
Mm-hmm. Okay.
But we don't have the whole genome sequence. We don't have the genotyping. We don't have the transcriptomics.
Exactly.
If you want that level of data, you've got to go to AMP-PD. Also, you've got all those cohorts harmonized.
Okay, so it's
you have a lot more power sample size wise there.
Understand perfectly. Okay, thank you.
With more cohorts coming too soon.
So the last thing I want to say is just to acknowledge everybody. This resource, this incredible resource, took a ton of people to get it together. So I want to acknowledge the cohorts, the Fox Foundation's PPMI, and our collaboration with them on BioFind. I want to acknowledge the Harvard Biomarkers study, which really did a lot of work with us. And I also want to thank the PDBP investigators because we couldn't have done it without you. And of course, I need to thank the patients because they're the ones who really put the effort and samples into this. And then lastly, I want to thank all of our partners and our committee and working group members who just did a ton of work to pull all this together. It was really an amazing effort by a lot of people. So on that note, I'll thank everybody who stuck with us this long for hanging in there. And I wish you happy data analyzing and hope that I see you tomorrow morning.
Did Walter have a question? I thought Walter.
I have a question.
Oh,
Judy
okay.
Paterno.
Hi, Judy.
I just asked one quick question. Is the RNA-seq data given as FASTQ data or expression matrices?
It's FASTQ. Or is it Dave, what is it? Do you remember?
It's muted.
The RNA, the transcriptomics?
David, you're muted.
Sorry about that. Offhand, I don't know. I know we do have FASTQs for that, but I don't.
Yeah, I think it's FASTQ.
Yeah.
That's correct. This is Aline Appelmans here. It's FASTQ. Yeah.
Thanks, Aline.
Thank you.
I just, hi, this is Shanjun again. Just I know we're closing, but just one last question from. I'm a computational biologist working in bioinformatics for almost 10 years, but I feel like I'm getting old because Google Cloud computing is something new I need to learn. And I'm very good at other like Linux, HPC, but to use this data more efficiently, you need to be very good at Google Cloud computing. I feel like this is a barrier for me. Maybe I'm not sure for other people as well. Do you have a plan that to give us some training on Google Cloud computing?
So I'm not sure, I don't think we currently have any Google Cloud training planned. But the nice thing about Google Cloud Computing is once you have your account and you can create a compute engine, which is just a Linux machine in the cloud. It acts just like any other Linux machine. And there are a number of command line tools like gsutil, gcloud that let you pull down the AMP-PD data into your cloud machine. So it's a fairly low bar once you get a compute engine set up and you get familiarized with those Google Cloud tools. I know Google Cloud themselves have a number of demos on how to use those command line tools and to create your compute engine. I don't know, Eileen, have we done any?
So we don't have any tutorials necessarily set up in this area, but this is also where if you email admin@ampd.org, and you can feel free to ask these type of questions, and we can connect you to those types of resources that could be helpful. So you can also email your specific scenarios or questions, and we can help walk you through to ensure that we get your questions answered.
Thank you, Elaine. Thank you, David.
Sure.
Okay, if there are no more questions, then, and if you think of some later, email us. We're happy to connect you with the proper support. So thank you again, and we'll see you tomorrow morning.
Thank you, Deb, and thank you, Ali Hajian, for your help as well on the questions.
Ali.
Yeah, no problem, no problem. And you can always, Terra has really good customer support. If you go under the top left menu, here I'll be visible. If you go to the top left menu in any Terra page and click on that and go to support, there's documentation, and there you can ask specific questions if you have, and there's a lot of resources available there for people to help get you started and to help get you through if you run into snags. So just a plug for that.
All right, thank you all so much, and we will be reconvening tomorrow morning, I believe at 10:30 a.m. again. So if you have any questions in the meantime, feel free to reach out to myself or Deb, and look forward to seeing you guys tomorrow. Take care. Bye.
Thank you very much.